Imagine standing on the coldest continent on Earth. No trees. No cities. No sound except the wind moving across millions of square kilometers of ice. Now imagine seeing something impossible, a glacier, bleeding. Bright red liquid slowly pours from the frozen landscape, staining the white ice the color of blood. And just when you think Antarctica couldn't become stranger, you discover something even more unbelievable. Deep within this frozen continent stands a volcano. Not an extinct volcano. Not an ancient mountain. But an active volcano, with molten rock glowing beneath the Antarctic sky. And inside its crater, there is a lake of lava. A lake that can remain molten even while surrounded by one of the coldest environments on Earth. So what exactly is happening beneath Antarctica? Why does a glacier appear to bleed? How can life survive in water trapped beneath hundreds of meters of ice? And why is there a volcano with molten lava sitting in the middle of the frozen Antarctic world? Tonight, we're going beneath the ice, and climbing toward the fire. Because these aren't legends. These are real Antarctic mysteries. Antarctica is often imagined as a continent covered entirely in endless snow and ice. But that image is incomplete. There are places in Antarctica where almost no snow falls. Places so dry that scientists classify them as polar deserts. One of the most remarkable is the McMurdo Dry Valleys, located in Victoria Land. Here, glaciers descend between enormous rocky mountains, while frozen lakes sit in valleys surrounded by barren terrain. And somewhere in this extreme landscape is Taylor Glacier. At first glance, Taylor Glacier looks like thousands of other glaciers around the world. White. Silent. Ancient. But at its terminus, something extraordinary happens. A strange liquid emerges from beneath the ice. And when it reaches the surface, it turns red. This phenomenon became known as blood falls. Blood falls looks almost supernatural. Against the brilliant white ice, dark crimson water appears to flow from the glacier. For decades, this strange color created an obvious question: what is making the glacier look like it's bleeding? The answer begins with something much more ordinary than blood. Iron. The liquid emerging from blood falls is an extremely salty brine containing dissolved iron. When this iron-rich water reaches the surface and encounters oxygen, the iron undergoes oxidation. In simple terms, the iron reacts with oxygen. And that reaction produces iron-rich minerals that create the spectacular reddish color. So the glacier isn't actually bleeding. But that explanation only solves the first mystery. Because now we have an even bigger question. Where is this liquid coming from? Imagine taking a knife and cutting vertically through Taylor Glacier. You would see layer after layer of ancient ice. But beneath that ice, there is something unexpected. Liquid. Scientists have found evidence that extremely salty brine exists beneath the glacier and in the surrounding subsurface environment. And this isn't simply ordinary fresh water trapped beneath ice. The brine is extraordinarily salty. That matters because salt changes the freezing point of water. Pure water freezes at 0 degrees Celsius. But when large amounts of salt are dissolved in water, its freezing point drops. This means that under the right conditions, extremely salty water can remain liquid even in temperatures far below the normal freezing point of water. And that gives us one of the keys to understanding blood falls. There is liquid water, in an environment that appears frozen solid. But then another question appears. How old is this hidden water? Scientists believe the brines in this region are connected to a much older geological history. The salts are thought to have marine origins, meaning that ancient seawater contributed to the chemistry of the system. Over immense periods of time, geological changes and advancing ice helped isolate these waters beneath the Antarctic landscape. The result is something almost like a natural time capsule. a chemical environment sealed away beneath the ice. And this is where Blood Falls becomes much more than a strange-looking waterfall. Because inside this dark, salty environment, scientists discovered something alive. There is no sunlight beneath the glacier. There are no green plants. No forests. No conventional food chain. And yet, microbial life exists there. Researchers have detected active microbial communities associated with the Blood Falls brine. These microorganisms survive using chemical reactions rather than depending directly on sunlight. Some of the energy comes from reactions involving substances such as iron and sulfur. Think about how extraordinary that is. On the surface, Antarctica is a world of freezing temperatures and intense environmental stress. Beneath the glacier is another world entirely. Dark, salty, cold, and yet, alive. Research has shown that subglacial and subsurface Antarctic environments can support microbial ecosystems, including organisms capable of obtaining energy through chemical processes. This is one reason Blood Falls is so important to scientists, because it gives us a glimpse into a type of environment that exists without sunlight. And that raises a question that reaches far beyond Antarctica. If life can survive beneath a glacier, could life survive somewhere else in our solar system? Scientists are especially interested in worlds where liquid water might exist beneath an icy surface. Mars, Europa, Enceladus. These worlds have something in common with Antarctica. They can contain extreme cold, ice salt, and potentially liquid water hidden beneath the surface. Blood Falls therefore acts as a kind of natural laboratory. It allows scientists to study how microorganisms can survive in cold, dark, chemically extreme environments. It doesn't prove that extraterrestrial life exists, but it helps us understand what kinds of environments might be capable of supporting life. And that makes Blood Falls one of Antarctica's most fascinating natural laboratories. But Blood Falls isn't the only place where Antarctica seems to defy expectations. Because only a few hundred kilometers away, something is happening that seems even more impossible. Imagine Antarctica at night. Temperatures plunge. The landscape disappears beneath darkness. Snow and ice stretch toward the horizon. And then, you see an orange glow. Not a research station. Not a campfire. Not a reflection. It's coming from the top of a mountain. A volcano. Its name is Mount Erebus. And it is one of the most extraordinary volcanoes on Earth. Mount Erebus rises on Ross Island in Antarctica. At approximately 3,794 meters high, it dominates the surrounding landscape, but its importance isn't simply its size. Mount Erebus is active. The U.S. National Science Foundation describes Erebus as Antarctica's only active volcano, and the volcano is famous for its persistent lava lake. Think about that for a moment. Antarctica is famous for ice. But beneath this frozen landscape, Earth's interior is still hot enough to melt rock. And at Mount Erebus, that molten rock can reach the surface. Inside Mount Erebus is one of its most remarkable features, a lava lake. A lava lake is essentially a persistent body of molten rock accumulated in a volcanic crater or vent. It isn't like a lake of water. It is rock, heated until it becomes liquid. And because magma continues moving upward from below, the lava can remain hot and molten. Mount Erebus has hosted a persistent lava lake for decades, making it one of the rare places on Earth where scientists can observe long-lived molten rock at the surface. But why doesn't the lava simply cool and solidify? The answer lies deep beneath the mountain. Beneath a volcano is a complicated system of magma reservoirs, fractures and conduits. Magma forms deep within Earth. It is less dense than the surrounding solid rock, so it can migrate upward. At Mount Erebus, researchers have studied the volcanic plumbing system beneath the mountain. NSF-supported research has identified a deep magma conduit that rises from the mantle region and interacts with shallower magma storage beneath the volcano. In other words, Mount Erebus isn't simply a mountain with a hole at the top. It is connected to a much deeper geological system. A system reaching down into Earth's interior. And this helps explain how molten rock can remain near the surface. Another fascinating part of the story is the geological setting. Mount Erebus lies within the West Antarctic Rift System. This is a region where Earth's crust has experienced stretching and rifting. When continental crust stretches, faults and fractures can develop. Those structures can provide pathways through which magma moves upward. NSF research describes Erebus as part of a continental rift environment and notes that its magma system is unusually rich in volatile components such as carbon dioxide. So the volcano exists because Antarctica isn't just a frozen continent. It is also a place of enormous geological forces. The ice may dominate the surface, but beneath it, Earth is still moving. Mount Erebus doesn't necessarily behave like the explosive volcanoes people often imagine. Its activity can include relatively small explosive events and the release of volcanic gases. The lava lake itself provides scientists with a rare window into volcanic processes. Molten rock rises. Gases escape. The lava circulates. And bubbles can form and burst at the surface. USGS research describes lava lakes as systems controlled by the balance between incoming hot magma and cooling and gas loss at the surface. That makes Erebus incredibly valuable scientifically. Instead of trying to understand what is happening kilometers beneath an inaccessible volcano, scientists can observe clues from the surface. It's almost like having a window into Earth's interior. And now we can see something remarkable. Blood Falls and Mount Erebus appear to represent completely opposite worlds. One is ice. The other is fire. One contains hidden liquid water beneath a glacier. The other contains molten rock beneath a frozen mountain. One hosts microscopic life in darkness. The other exposes material originating deep inside Earth. Yet both are connected by the same thing. Antarctica is not dead. It is an active geological and biological system. Beneath the ice, water moves. Microorganisms survive. Rock is weathered. Heat rises. Magma travels. And volcanoes breathe. But perhaps the most fascinating question isn't what scientists have already discovered. It's what they haven't. Antarctica hides enormous parts of its landscape beneath kilometers of ice. Scientists have discovered subglacial lakes, buried mountains, ancient geological structures and microbial ecosystems. Yet much of the continent remains extremely difficult to access. Every new radar survey, every drilling project, every seismic measurement, can reveal another piece of the hidden Antarctic world. And Blood Falls gives us a warning. Sometimes, the evidence of an entire hidden ecosystem can appear as something as small as a red stain on a glacier. Mount Erebus gives us another warning. Even beneath one of Earth's coldest landscapes, the planet's internal heat is still alive. Antarctica is often described as a frozen continent. But perhaps that's the wrong way to think about it. Because beneath the ice, there is movement. There is water. There is chemistry. There is life. And there is fire. Blood Falls reminds us that an apparently frozen world can contain hidden water and living organisms in complete darkness. Mount Erebus reminds us that beneath the ice is still the restless Earth itself. And together, they reveal something extraordinary. Antarctica isn't simply a place where life struggles to survive. It is a place where life, water, ice, and fire, exist side by side. And perhaps the greatest mystery is still waiting beneath the surface. Because if scientists can find life in an underground Antarctic brine, and molten rock beneath an icy landscape, what else could be hiding beneath the millions of square kilometers of ice that we have barely explored? Maybe Antarctica's greatest secrets aren't on the surface. Maybe they are underneath our feet. And perhaps we've only just begun to look.